Bonjour à toutes et tous. So welcome, good morning. We'll have the opportunity to exchange about the challenges of the existing French nuclear fleet. So the Grand Carénage and the LTO program, long-term operation program, and also the challenges of the climate change. So let's start with the nuclear French fleet. So why and how to continue the operation? First of all, we have 57 reactors all around the French, all around France. And as you can see, there was really a boom at the beginning of the 80s. So 32 reactors have started between 1979 and 1988. So it means when it will come to the end, who knows if it will be 50 years, 60 years, 70 years, 80 years. But anyway, as you can see, it's a kind of cliff. So we will have to think to what will be the future and also to plan when we will shut down definitively the reactors and when there will be the opportunity for the EPR2 to take the lead. Oh, sorry. Yes. What about what is happening all around us? Why continuing after 60 years of operation? Our fleet is quite young because it's 37 years old in average. And as you can see, in Switzerland, in the US, in Belgium, there are many reactors older than the French fleet. And some of them are more than 50 and close to 60 years. So this is very powerful in terms of return on experience. Most of them are PWR, so pressurized water reactors, so same technology. It's quite easy to have benchmark and to share experience with them. What are the key milestones in France for the French nuclear fleet? In 2022, our Nuclear Safety Authority decided the pursuit of the 900 megawatt fleet. So we have 32 reactors of this type. And it was the way that we could go from, so this is the visit, so the periodic safety review at the age of 40 years. So to go from 40 to 50 years, because in France, it is by 10 years that we have the authorization for the Nuclear Safety Authority. So in 21, we decided to launch this fourth periodic safety program, different discussion with the Nuclear Safety Authority. And by the end of 2026, because we send them a lot of data considering going beyond 60 years, the Nuclear Safety Authority will send to the French government what is the position of the authority regarding operating beyond 60 years. We say beyond 60 years because we don't know if it will be 70, 80. So beyond 60, that means it seems that there will be a fixed periodic safety review, so meaning that we will go from 60 to 70 years. But for some technical side, we are also putting the data and also calculating what it's going to mean for 80 years. So this is data that we are providing, and we'll see what will be the opportunity. But for sure, in France, and I think it will remain like this, it's each 10 years that we obtain the authorization for 10 years more. When you look at the calendar, regarding the different fleets. For the 900 megawatt fleet, it means that this 6 periodic review will start in 2039. And if you look at the N4, so the 1450 megawatts, it will start in 2059. So quite long from here. But it's really the opportunity to speak about that and to prepare also the industrial partners. How do we proceed for this periodic review? Because as you can see, it's 2060. In 2060, there will be a lot of things changing, and for sure, the climate change. So it's also one specific part that we are working on. So anticipated the expected first. How do we anticipate that? Each 10 years, we have a safety reassessment. So it means that we take the standards, so the safety standards of the moment. For example, for the French fleet, we are right now proceeding the 4th periodic safety review, and the standard, so it means that we are proceeding to modification on the plants, and the standard is the EPR, so European Pressurized Reactor. This is the most available safety standard in France, so this is the reference, and it means that we are proceeding a lot of modification. The outage lasts around 6 months, so we modified the design. And each 10 years, we proceed to this safety reassessment, and it means that sometimes, by calculation, we can prove that the safety is still okay, even with new norms, and sometimes you need to proceed to design modification. I told you about the climate change. It's also one specific topic very important. Because, as you know, 2 degrees by the end of the century, it's no more possible. So it will be a lot of more, probably close to 4 degrees, unfortunately. And so we are working with Météo France and all different organisms, the data from the GIEC, and by 2060, to take an example, because this is the age of the 6th periodic safety review for the N4, so the 1500 megawatts. So in 2060, what will be the climate for Chaux? It is in the Ardennes, and Civaux. So this is the two plants where we have to think about what will be the 6th periodic review in 2060 or 59 for these plants. So we are really working on that, doing some projection, and also find way to reduce consumption of water and electricity, and to work on resilience. So safety level, as I told you, each 10 years we have design modification, design improvements. For example, for the 4th periodic safety review that are proceeding right now, for the 900 megawatt fleet, we have already completed almost 25 PSR, so the 4th PSR. There will be the complement to 32, because we have 32 reactors. And for the 1300 megawatts, it will start in parallel in some months at the beginning of the year of 2026. So what are we doing? So it's Gen 3, so the reference is UPR, EPR, as I told you. And we have added safety system of water and electric supply. This is directly the operating experience of the Fukushima event. Extreme hazard protection, so hardened safety core. Improvement towards severe accidents, so more accident, meaning that regarding what we will reject in case of accident. There will be it will be close to zero. We are aiming zero nuclear waste from an accident. And also, we added diversified heat sink for core and spent fuel pool cooling. Climate change resilience. This is also a topic of different design improvement regarding tornado, high winds, cold, extreme hot. But as I told you, because climate change is going faster than expected, we are really thinking for the fifth PSR, fifth periodic safety review, so starting in 2029 in Tricastin, that this periodic safety review will be really focused on climate change modification, so design improvement. For safety, in 10 years, no more big standards have evolved. So we have three complementary approaches of the program Grand Carénage. First of all, because our plants have 40 years, close to 50 years, we proceed to a replacement of big major part of the installation. For example, the steam generator, but also on the turbine, in the turbine hall, some turbine retrofit. So second, it's anticipated work at full power, so replacing primary circuit section, and also strong collaboration of the project between engineering, site, operator, and supply chain. This is really what we call the recipe of the Grand Carénage. This is this cooperation between the operation part. They are really embarked in the modification, so close to the engineering center, to interact during the design or the redesign phase, just to make sure that by implementation it will be quite easy on the station, but also for the maintenance and the operation. So this is the way that we are really connecting supplier, engineering, and also operators very early. And donc you have three pictures of what could be done during this major retrofit or a major periodic safety review. Concerning the climate change, we decided to launch a program. So this program has really a systemic approach, meaning that it's looking around the system and not only focused on the plant. So what are the data? What will evolve in the system? What will be also the interaction, especially regarding the telecom, for example, because if we don't have telecom for many hours or days, we will have quite difficulties to operate after a major disaster coming from climate. So this is systemic and also very connected with outside of the plant. Understand climate change. So we have an R&D team, a very specific R&D with climate scientists, assess the effect, and also mobilize and act. And as I told you, we will proceed to design modification. The systematic approach is applied to nature and water resources, the industrial facility, the supply chain, resilience capacity. So this is one example, connecting with outside. Will we have enough, I don't know, fuel or things that we need to operate durably the station? What will be the way of communication with the station? So we are really working with outside the plant, just to make sure that in case of events, this is resilient in a systemic approach. And also, for sure, the socio-economical and natural local environment. This slide show you how do we proceed to anticipate. So you have the initial design for the existing reactors. With the periodic safety review, some design modifications, design improvements. And also, so this is the last step, in a sense. In long-term operation, what will change? So it's a prospection, it's perspective, because there are different scenarios, and we don't know exactly. So we are looking at different scenarios and then projecting what could be the evolution, and how do we anticipate? What do we have to do to anticipate, just to make sure that we'll be on time once we will aim the objective of, as I told you, 60 years or 70 years or 80 years for our station. Concerning climate change, these are the main parameters that we are seeking and also monitoring. So the increase of air temperature, it will be one challenge. The increase of water temperature, especially for the cold water that we use to refresh our process. The sea level, this is for the stations that are close to the sea. The water temperature is much more for the station close to the river. Even so, for the sea, it's also one aspect. And draft, we know that draft will be longer and more intense. So this is also something that we have to take into account, especially concerning the water that we use to cool the reactors. The good news is that when we do the projection, what will be the climate in each station by 2060, by 2070. The good news is that somewhere in the world, one station is still facing the same climate. So that's the reason why we have the opportunity to exchange with colleagues from Baraka, so in the Emirates, in South Africa, in the desert, in the US, close to Phoenix, because they are facing what we will probably face in 20, 30 years from now. And so this is the opportunity to exchange on how do they do for the resilience, considering water consumption, and also temperature. And they have technology for that. So for sure, it was usually embarked by design. But anyway, as you can see, in France, we are quite keen on design modification. So we will proceed also on that if necessary. I will go faster on this slide just to make sure, yes, it's going to be okay. So as I told you, there are many options possible, and that's the reason why we do this projection. So it prepares us for what could be the future, even though we are doing a better job on CO2 emission, and in case of it won't be the case in the world. And we are working with all these known and renowned foreigner and also French organism, just to make sure that this is good data. And with a periodic climate watch each 5 years, sorry. So each 5 years we make a stop, or if there is a climate event in the world, but each 5 years we really do a very focused and deep climate stop, just to process on this projection. What are the challenges also for LTO? Because I had a lot of examples regarding climate change, but also on the installation. So, as you know, there are some parts of a reactor that replacement is not possible. So this is the case of the reactor vessel, pressure vessel. And so we are monitoring how the aging is going all over each 10 years. And we also have the opportunity to change the fuel management just to protect better the vessel. The biological shield wall, once again, it's a part that it's not possible really to change it. So same thing. We are monitoring that just to make sure and to demonstrate to the Nuclear Safety Authority that the property are still okay for 10 years more. There are some components that are difficult to replace. This is the case of the vessel internals, even though colleagues in Japan have proceeded to replacement, so it's possible. It's complicated, but it's possible. The elbows just emerging from the vessel, so we call them the ECAS elbows. This is a part where there are a lot of radiation, and on top of that, if you, because you have to weld when you replace this elbow, if the weld is not well done, so this is the end of the life of your vessel and the pipes. So for sure, if we can not proceed on the replacement, it also will be better in terms of risk management and cables. There are kilometers of cables in a station. Some are easy to replace, some other are not so easy to replace. So we are also monitoring how the aging process is going on these cables. Some other replacement components, it's not always easy part. For example, INC. We know that if we go to 60 years for sure, and it will happen before, for the 1450 megawatts and also the 1300 fleet, because there are a lot of more numerical part and INC of the last generation. Because of obsolescence and also aging, we will have to replace them at the age of 50, 60 maybe. So for that, we are really, we have a lot of partnership regarding innovation, because this design improvement modification, it meets a lot of innovation, new technology, even though in the nuclear we we try to implement technology that are sure. So it's not the when I say new, it's not the technology from yesterday, but it is more recent than in the design, and usually it's 5 to 10 years of demonstration of safety and reliability at all. So this is the end of my presentation. Thank you very much. So we can go on the other side to have some exchange. Thank you.